On this delta math, we're talking about the distance between 2 points, okay? And I know you guys love to think you could just magically count and estimate this perfect distance between these two yellow points, but I'm sorry, you cannot, because they are not perfect. But what is perfect is like going perfectly up and down, that's vertical or horizontal. So what they tell you to do, if you want to know the distance between these two yellow points, is use the tools that we've learned this year. And one of those has been a magical theorem brought to you by our friend Pythagoras, the Pythagorean theorem, which still about only 5% of my students can actually say without messing up. No offense, but it's just a struggle. We're on the struggle bus. Okay, so what you do is you draw a straight line going down and then a straight line going across, okay? And you can count those edges. Those are sure amounts of edges. You know this one's 2, and this one is 1, 2, 3, 4, 5, 6, 7, 8, 9 perfect side edges of those squares. So 2 and 9. So what they tell you to do is label them. Those are your legs. And what did we do? We made a right triangle. We are so amazing. You could have actually made one going up and over, but it would have been the same thing, just turned a different direction. So this one's fine too. So just understand there's more than one way to do it. And these are the legs when we're doing the Pythagorean theorem. Those are the legs. And so we go ahead and square those and add them up. And they're going to equal the distance of this one when we square it. So 9 squared and 2 squared is going to be c squared. 9 squared is not 9 times 9. Sorry, it is 9 times 9. It's not 9 times 2. I'm tired. Okay, 9 times 9 is 81. 2 times 2 is 4. Combine those puppies, you get 85. And 85 equals c squared, not c squared. Okay, so in order to do that, we do the inverse operation of squaring, which is finding the square root. And when you do that, see, I like to slash things out. Slash, slash. Now we have just c. We know the square root of 85. If we put that into a calculator and they tell us to round, be careful, round appropriately. The nearest tenth is 1 decimal out. Okay, so now that we know that, we can label what is our missing distance, 9.2. And so you have to plug in the 2 legs. They don't care the order. This could be 9, 2 or 2, 9. Okay, and then this distance is 9.2 if you rounded correctly. All right, same idea, new problem, 2 different points. Okay, these are the 2 points that they give you. Okay, and then you're going to go back in and you're going to make those beautiful straight lines using the Pythagorean theorem. And when you do, you're going to count them up and see how long those lines are. This one is 8 and this one is 6. Okay, and when you do that, you're going to plug in those as your legs on your Pythagorean theorem. So a squared plus b squared, so 6 squared plus 8 squared. Simplify those. 6 times 6 is 36. 8 times 8 is 64. Combine to get 100. Right there. 100 equals c squared. Maybe you know right away. Say, oh, what number times itself twice is 100? 10. Okay, or if you're not sure, that's fine. Okay, something squared and something square rooted, those are inverse operations. That's going to give us just our plain c. And it's not approximately 10, it is exactly 10. They didn't even need to put that wavy little equal sign in there. Okay, this distance right here is exactly 10. You don't even have to round. Okay, and then label those so they know that you know what you're talking about because your teacher taught you.